In the last section, we got to the conclusion that the MOSFET was not saturated. It was not in saturation region, so we couldn't use this equation, but we had to use this equation. So, to be able to use this equation, we can notice that we need this, but we are given these two factors: the width, the length, the process transconductance parameter. We have in BGS, we have the threshold voltage, but we don't have the voltage drop. We don't know the voltage drop, and we don't know the current. So we have two unknowns. What do? Well, we do know that the voltage drop, we could do a KBL, saying that BDD minus the current, minus this resistance, times the current that's going to be flowing through here, ID, minus BDS equals 0. And what we could do is, oh, we already have it right here. We already have that same equation right here. Nice. And knowing this, we could substitute this into this equation. So what will we be left with? We'll be left with doing it kind of quickly, just copying and pasting, because this, well, I'm gonna do it by hand. Minus, let's cut this. Minus 1/2 BDD minus 1 kilo and all this square. This is our equation. We could start substituting. I'm gonna just start substituting. We have ID equals 500 micro, 100 micro, 10 micro. We have here 4 minus 2 times BDD, that's 6, minus 1,000 ID minus 1/2, 6, 1,000 ID squared. We could solve this right here, and it's gonna be could solve this right here, and we have 2 times 6 minus 1,000 ID minus 1/2. We could solve this right here, and this is going to be 6 squared minus 2 times 6 times 1,000 ID plus 1,000 square ID square. And we're gonna, so this could cancel, and we're gonna pass it here. So we have 2 times 6 is 12 minus 2,000 ID. And here we have this times this, this times this, and this times this. It's going to be negative 6 to the 2 plus 6,000, because the 2 cancels with this 2, get 6,000 plus, negative minus ID. We're going to equal everything to 0. Okay. So this is looking good. This is looking good. We could regroup this and this and this and this right here. We could say 12 minus 36 over 2, negative 6. And negative 2,000 plus 6,000 is 4,000, and 10,000 be 5. Okay, we are almost done. So we have negative 6 over 200. We have 4,000 ID over 200. Negative 500K ID square over 200. All that minus ID equals 0. And if you notice, this would be 2,500 ID square plus 4,000 over 200, 20 ID minus 6 over 200, 0.03 minus ID equals 0. And you could have done this in your calculator if you have calculator that does this. I have one here, but I'm doing it so just in case you don't have that type of calculator. But this is a Texas Instrument, the TI 89 titanium, that you can insert this equation right here. Oh, sorry. You can insert this equation right here, and I'll give you the two values, two results, because it's a polynomial. So we have a, oh, sorry, this is negative. This is negative. So we have this polynomial. So we know we're gonna get two results. And you could use your calculator, or you could do it by hand. I'm gonna use my calculator because I understand that you could deal with this. Round it out. So these are the two values that I got. Okay, now the issue, we're almost running out of time. The issue is, which of the currents is it? Well, remember that we have an equation here that states that for us to be in saturation mode, this equation has to be true. And we have this equation here. So we could substitute ID here and find out what is the value of DS, voltage, the voltage DS, and see if the equation is true. Let's do that. I'm gonna start with 5.36 milli because I know that's the value, and the time is almost running. So yeah, which is dt minus 1000 ID 6 minus 1000 times and this is gonna be 6 minus 1000, 5.362 point volts. So that's B DS. Okay, now the equation that we have to determine is if the BDS is greater than BG minus VT, VGS, 0.638, is it greater than 4 minus, wait a second. Okay, so I wrote this equation incorrectly. It's supposed to be that the voltage DS is minus, or I mean it's less than voltage BGS minus VT. And in that case, that's true. So this current here is the one that you'll use as your Qpoint current.